Hello everyone, welcome to the VLab platform. My name is Umar Adamu, an engineer and a technologist in the Department of Electrical and Computing Engineering based University of Abuja. Today we are going to perform or conduct a practical or experiment on series and parallel connection of resistors. We are expecting listeners to pay total attention throughout this experiment in order to avoid making mistakes during practice. The aim of this experiment is to understand the characteristics of resistors when connected in series and parallel. Resistors are electronic components or devices that are used in building electronic circuit which opposes the flow of current when connected in the circuit. The resistors can be connected in parallel or in series or in both parallel and series. In a series circuit, all components are connected end to end, forming a single path for current flow. While in a parallel connection, all components are connected across each other, forming exactly two sets of electrical common points. To carry out this experiment, certain apparatus or components are needed. Trainer kits, the resistors, the digital multimeter, the jumper wires, and DC power supplies, which in this case is an inbuilt in the trainer kit. Connection. This is a simple circuit diagram that shows how resistors are connected in series. So we are now continuing with the experiment using the following apparatus. The apparatus needed for the experiment are, we have our basic electricity lab, which is the electronic kit. We have our bank of resistors. We have our digital multimeter for measuring voltage, current, and resistance. We also have our connecting probes or connection wires that we can use to achieve the experiment. In the first place, these are my resistors. This is my 220 ohm resistor. And I'm starting with what? Parallel connection. So, for the parallel connection, these resistors are connected on the trainer board, which I put here. And then, this is my positive This is my third resistor, which is 230 ohm. These are my jumper wires for connection. This is my negative to any end of the resistors. This is my positive through a switch provided on the trainer board. Output from the switch to the other end of the resistor. I have now finished my connections and I have confirmed that all my components are intact, are properly connected on the trainer board. I have switched on my trainer board and switched on my toggle switch on the trainer board to supply the resistors. So first of all, I'm starting with what? Voltage measurement. For voltage measurement, select the voltage range on my digital multimeter, which I have for voltage measurement. So, and as it is stated in the steps and in the theory there, it is measuring voltage is what? Across. You place your measuring leads of your multimeter across the component. So, this is the voltage I obtain. It was 5.01 volts. This is for parallel connection. it is 5.01 volt. So that is the voltage. And since the resistors are connected in parallel, it means the voltage across them is the same throughout, even if they are 100. So in this case, the resistors are 3 in number. So we have the same 5.01 volt across the 3 resistors. 5.01 volt. Then for current measurement, the resistors are all connected in parallel. But for current measurement, the measuring instrument, which is my multimeter, needs to be connected in series with the component or with the resistors to be measured. So this is how it is done. I take my negative lead to the negative terminal and positive to the positive terminal of my measuring of my component, and then select the proper range for what current measurement. This is my milliamp. So my current is 0.4 milliamp. So that is my current across what these 3 resistors. Also, for the resistance in series, I have to disconnect the previous connections, switch on my trainer board, and then reconnect or rearrange my resistors in series form for the second experiment. This is my 220 ohm resistor, 200 ohm resistor, followed by 220 ohm resistor, followed by my 330 ohm resistor. This is my series connection. Then my negative to one end of the resistor, and then my positive to the other end of the resistor. I now switch on my trainer kit and also switch on the toggle switch, and then select the proper range on my digital multimeter to measure the voltage on each of these resistors or across each of these resistors. My voltage across R1 is my voltage across R1 is 1.32 volt. Across R2 is 1.46 volt. Across R3 is 2.18 volt. For my current, I should select the proper range on the multimeter for current measurement. Current measurement, and you should know in measuring current, the measuring instrument have to be in series with the component to be measured. So half my current is 0.5 milliamp for R1, for R2. Okay, for R2 the measurement is the same through the resistors connected in series. For R2 is 22.4 milliamp, for R3 is 14.9 milliampere. And also for the measured resistance is the same as the previous measurement, which is 199.8 ohm. Second resistor is 221 ohm, and the third resistor is 331 ohm, respectively. So these are the measurements, or these are the readings obtained for measuring current and voltage across resistors connected in series and in parallel. From the experiment performed, it is observed that resistors connected in series have high resistance compared to resistors connected in parallel. Also, for resistors connected in series, the current depends on individual resistance, while for resistors connected in parallel, the current also depends on individual resistance. For voltage across resistors connected in parallel, the voltage is the same across the resistors, while in current, the voltage depends on individual resistor. So it is observed that in series connection, we obtain high resistance, while in parallel connection, we will obtain lower resistance. And also in series connection, the voltage is dependent on the individual resistance, while in parallel connection, the voltage is the same across all resistors, irrespective of their values. If it is 1 kilo ohm, either 100 ohms, if they are connected in parallel, the voltage across them is the same, and at the same time, the resistance across them is the same. So this is where we come to an end of this experiment for today. Thank you.